provides accurate instructions for how to make a dry electric battery.
The battery doesn't show up in our conventional technology until the 19th century. What the heck is it doing in the Agastya Samhita, the sacred text that was Agastya's personal writings? If Agastya knew how to build a battery, then how can we rule out all of the other marvelous technology that is described in the same document?
On March 31st, 2016, author and researcher David Childress met with physics professor Dr. Michael Dennin at the University of California, Irvine, to put Sage Agastya's centuries-old instructions for building a battery to the test.
So we need a well-cleaned copper plate.
Okay, so that's the copper plate here. That's going to make one end of our battery.
All right. And we need an earthenware vessel.
We've actually chosen to substitute that with a plastic petri dish. All that vessel is an insulator to hold our battery. These are transparent, so we can look inside while we do our test.
And then we need copper sulfate.
So we've got some copper sulfate solution here. It's a liquid and it's blue. That tells you about the copper inside.
Okay, and we need moist sawdust.
We're going to actually start with dry sawdust, and when we add the copper sulfate in our battery, it'll become our moist sawdust.
Okay, and then we need a zinc plate.
So finally, the silver-looking plates, those are our zinc plates. That makes the other end of the battery.
All right, let's see how this works then.
Okay, so we start with the copper plate. As they said, you put that at the bottom, and then we add the sawdust.
Okay, what does the sawdust do?
Well, one of the important things in the battery is to make sure the two metals don't touch each other. They have to stay separated or the battery is shorted out. Now we're going to add zinc on top. Now we're going to add the copper sulfate.
What does that do?
So this is our electrolyte solution. It's a key element to the battery. It's going to cause the chemical reaction that'll take electrons from one of the metals and allow them to flow to the other metal, and that'll give us our current and our battery. Now we're going to take our voltmeter and we're going to check and see what sort of voltage we're getting out of this battery. And as you can see, we've got 1 volt on the voltmeter. So our battery is actually working and running.
Wow, and this really validates this ancient text. So what can you do with 1 volt?
Well, with 1 volt and a typical single battery like this, the cool thing is you have enough energy content that you can lift a person, say a 200-pound person, about 10 meters into the air if you have the right machinery to hook this battery up to.
Wow.
A battery with enough power to lift a person off the ground? Could the technology described by Sage Agastya